The heart is a muscle that pumps blood and oxygen to all parts of the body. It has 4 chambers, 2 at the top and 2 at the bottom. The right side of the heart receives blood that is low on oxygen. It is pumped into the lungs and reoxygenated. The left side of the heart receives the oxygen-rich blood and pumps it into the body. The heart's natural electrical system sends impulses to the chambers in 2 consecutive phases. This causes them to contract, which pumps the blood through the body. This is called normal sinus rhythm. When an irregular or abnormal heart rhythm occurs, it can cause the heart to suddenly stop beating. This is known as sudden cardiac arrest, or SCA. During an episode of ventricular fibrillation, or VF, the heart shows a dangerously fast heart rhythm, which causes it to quiver rapidly so it cannot pump blood or oxygen throughout the body. This rhythm can cause the heart to stop beating. An electric shock can stop this rhythm and return the heart's rhythm back to normal. VF can happen at any time to anyone. If not treated within minutes, it can lead to death. People at risk of a sudden cardiac arrest can be protected with a small implantable device called a defibrillator. It automatically detects an irregular heart rhythm and produces an electric shock to return the heart to its normal rhythm. The subcutaneous defibrillator, or S ICD, leaves the heart and blood vessels untouched at all times. Its electrode is placed just under the skin above the breastbone, and the pulse generator is implanted on the left side of the chest. Depending on the doctor's usual practice, a local or general anesthetic is given to make the patient comfortable during the 1-hour procedure. An incision is made on the left side of the chest. A pocket is formed under the skin where the S ICD device is fitted. 2 small incisions to the left of the breastbone allow the electrode from the S ICD to be placed just under the skin. The electrode is then attached to the S ICD device. Once the system has been implanted, most doctors test the defibrillator and adjust the settings to work best for the patient's heart. This includes inducing an irregular heart rhythm, allowing the S ICD system to detect it and automatically restore normal sinus rhythm. Finally, the doctor closes the incisions to complete the procedure. A transvenous ICD connects to the inner walls of the heart with 1 to 3 leads. These leads are fed through a vein across the heart valve into the heart. The pulse generator is implanted on the left side near the collarbone. Depending on the doctor's usual practice, a local or general anesthetic is given to make the patient comfortable. The procedure normally takes an hour. It can be longer depending on how many leads the device has. A small incision is made near the collarbone. Using X-ray imaging, the lead or leads from the ICD are inserted through a vein and placed inside the heart, where they are fixated to the heart muscle. On the upper left side of the chest near the collarbone, a pocket is formed under the skin where the ICD is fitted. The lead or leads are then attached to the ICD. Once implanted, most doctors test the device and adjust the settings to work best for the patient's heart. This includes inducing an irregular heart rhythm and allowing the ICD to detect it and restore the normal rhythm automatically. Finally, the doctor closes the incision to complete the procedure.